Hello, very good evening. Please let me know I am audible and I am visible in the chat box. You know the drill. Please let me know. All right. All right. So you guys can see me, you guys can hear me. Please let me know in the chat box so I can know and I can start my class. All right. A very good evening to all of you. A very good evening indeed. Very nice, very nice. So, all right, ladies and gentlemen, all right, my sailors, we have the last lecture on electrochemistry. This is all about electrolytic cell, and this chapter is also very important for your metallurgy. Metallurgy, कुछ बातें बताऊंगा, some points I would discuss that I would also discuss in metallurgy, and I will connect the dots. So pay full attention in this beautiful lecture of electrochemistry, and it is the last lecture. So are we guys ready? Are we excited? Is the Josh full on? Let me know in the chat box. है ना? And yes, my name is Harsh Maheshwari. If you are coming and watching me for the very first time, I am an alumnus of NIT Warangal and I believe in one thing. जो करो मजे से करो वरना करो ही मत ठीक है Put your best in. That's what I believe, firmly believe. All right, moving on. Boys and girls, this is our daily schedule. Make sure you take a screenshot. I'm not gonna come up this week. Suri sir is gonna come up, so make sure you watch him. And then you have also, I am coming next week on Monday. You have this calendar. This will be repeated. So it's like a never ending loop. Inception देखिए क्या हम हर रोज आएंगे हर रोज पढ़ाएंगे ठीक है आपके सपनों में भी पढ़ाएंगे. All right, moving on. आगे बढ़ता हूँ. Boys and girls, what you are seeing here, we are teaching you, we are giving you a plan and everything, but still there is like, if there is, you are lacking some seriousness, that seriousness can be achieved in our paid version, which right now is up for free. You have to go into the description box and you can be learning from the best teachers across India, all over from India, the best teachers are all over from India. You can learn from us, right? So what will happen here? It will be 100% live classes. Doubt discussion would be live. Tests would be there. Material you would get. Most important thing, content you will get for your JEE 2021 preparation. You will get the content. You will get the questions. You will get the doubt clearance. You will get the test. Right now it's up for free, so do check it out in the description box. What is it all about? And it is up for free, so you can actually try that as well. All right, moving on. Boys and girls, if you haven't subscribed, please make sure you subscribe because we are teaching every day here on our beautiful JEE, channel, JEE channel, and you have to be a part of it. Hit the bell icon so you would be notified when your favorite teacher is up online. All right, okay, my sailors. So shall we begin? बच्चे बढ़ रहे हैं, मजा आ रहा है. Shall we begin? Yes or no? Let me know. I am so excited for this chapter, or this topic, I should say. Waiting for your response. Apparently, it's slow. Very nice. Very good. Yes, Rishita, I'll try my best. All right, Yogesh. All right, Pooja. Let's start the session. Yes, so all of you are ready. Yes, Sanjeev. Yes, Mukesh. Yes, Anjani. Let's start. Time to start. What is electrolytic cell? It is completely the opposite thing what we have been learning from last 4 lecture, right? This basically, what does it do? It is a cell which converts your electrical energy into chemical energy. Sometimes you want to convert your product into some other things, right? Or sometimes you want to convert your reactant into some useful product. I said it wrong first time. So you want your compound to give you more useful product, and it is not happening spontaneously. So what you do, you pass electricity and force it to undergo a reaction. Previous cell was called as galvanic cell, in which you were creating electricity by doing some wonderful magical reactions. It was not magic, it was pure chemistry, right? So we were doing some chemical reactions, from that we were generating electricity. In this, we are doing exactly the opposite. What we are doing, actually we are passing electricity and causing a reaction to happen. So it's completely reverse. Very, very important thing. It is completely reverse. I hope this point is clear. Now, what is the comparison? What is the difference? Let me tell you. Let me educate you here. Okay? Let me give you full education. Achha, I thought the screen was not coming properly. So I'm just, you can take a screenshot of it, or you can understand, you can read the statement. All right. Now check this out. If I talk about the cell under investigation right now, that is electrolytic cell. Electrolytic cell is basically, you are going to hook up a battery, right? You will have a battery. This is your positive end. This is your negative end. Negative end is called as cathode. Positive end is called as anode. This is the only difference. Previously, anode was negative. Here, anode is positive. But what happens at anode? Oxidation only. It is just like your physics. You know, in physics, you use battery a lot. Anode is oxidation, and the terminal is positive, and cathode is negative. The terminal is negative, and here reduction happens, right? It is right. You are passing the electricity by help of a battery, by the help of a बैटरी, राइट? सो बैटरी से आप इलेक्ट्रिसिटी पास करते हो सेल के अंदर और वहां पर रिएक्शन शुरू हो जाती है. इन गैल्वेनिक सेल इट वाज कंप्लीटली द रिवर्स, completely opposite. You are actually creating chemical energy, or you're creating a reaction by by sorry, I said it wrong. By doing the reaction, you are generating electricity, right? In galvanic cell, anode was negative, cathode was positive, and at oxidation always occurred at anode. Cathode पे हमेशा reduction ही होगा. I think it's better now. No lag. Are we fine? There is no lag now. I can see. Be patient with me, beta. अब lag नहीं है. There is no lag now. I am hiding my screen right now. I think lag is not there. Shall I continue? सब सुन पा रहे हैं? Everyone is able to hear me? All right. All right. ठीक है. ध्यान देना. So pay attention. In galvanic cell, you were converting your you were converting your chemical energy into electrical energy. Electrolytic cell is completely the reverse. You are creating, you are passing electricity and creating a chemical reaction. That's the difference. Anode is off here. In galvanic cell, anode was negative, but in electrolytic cell, anode is positive. It is just like you are hooking up to a battery. That's it. Best example I will tell, what is the use of electrolytic cell. Sometimes we want to convert our compound into some useful product. I want to do some extraction. I want to extract a metal from its aqueous solution, from its molten solution. I want to purify a metal. That's where you use electrolytic cell. It is very, very important in your industry. It will be also coming back again in the chapter called metallurgy. Because we need to pure our metal which we are extracting from different processes, we use electrolytic cell in that process. Okay? So we will learn that. Okay? We will learn that. All right, beta. Check out the construction. I am back again. You can see me now. Hi. So now check it out. So now check out the construction. Construction is very important. What you do, you take up the cell, hook up a battery to some electrodes, right? Let's say this is your positive, right? This is your positive end. This is your negative end. Negative end is called as cathode. Positive end is called as anode. Anode पे oxidation ही होगा बेटा. Anode पे always oxidation will take place. Cathode पे हमेशा you will get reduction. You will always get reduction. Okay, this is also clear. Now what else beta? What else will happen? Again, I have to say bye bye for my screen. Now check it out. So this is gonna happen. I'm gonna add here, for example, I have taken molten MgCl2. Acha. So in molten MgCl2, you will get Mg plus 2 ion and Cl minus ion. Okay? You will get Mg plus 2 ion and Cl minus ion. Check this out. Anode is of positive charge. So Cl minus would be attracted here. It will go here. If I talk about Mg plus 2, Mg plus 2 would be attracted at cathode. So you will get your metal out of your molten solution. Did you understand? Check this out. What is happening at cathode? What is the reaction happening? Reduction. Mg plus 2 moved there from the solution and got deposited, and you were able to extract magnesium from your molten solution. Similarly, beta, chlorine gas will go here, and or I should say chloride ion will move towards anode and give you chlorine gas. So you have separated your metal from its solution. Isn't that so? ऐसा ही हुआ है, हाँ या ना? Is that what happened? Yes. How simple is it? So you have extracted your metal from its molten solution by using this principle. You have applied electrical energy and you got a chemical reaction out of it. So it's completely the reverse. I hope everything is understandable, everything is crystal clear. This is your battery. This is your battery, and battery is providing electrons in the electrodes which you are hooking up to the battery. Electrons are provided here by the battery, but in galvanic cell the electrons were given by the anode oxidation. I hope it was clear that time. Again, I am repeating that particular point. The electrons were generated in galvanic cell by the oxidation process at anode, but here who is doing the magic? Your battery is giving you the electrons. I hope it is clear. I hope ये मजा आ रहा है सुनने में. ठीक है? ये सबको clear है? This is the setup. This is the setup. All right. Moving on. Let's learn more. Now, beta, for understanding it much better, I would ask you to learn these reactions which I have given here. What is the oxidation of H2O? H2O will give you oxygen gas, right? Balance the reaction. So you are getting, two hydrogen got unbalanced. So you have written 4H plus. Now you see charge you have to also balance. So you have to add 4 electrons. This process is called as oxidation. This process is called as oxidation, right? Boys and girls, if you check out in your oxidation process, H plus was generated. So when you will do oxidation of water at anode, the concentration of H plus ion will increase. If the concentration of H plus ion will increase, pH will decrease, because pH is equal to minus log of hydronium ion concentration, right? They have inverse relationship, right? As a result, pOH will increase, right? I hope I am telling you the right points. सबको समझ आ गया? If H plus ion concentration will increase, pH will decrease, correct? That's what is going to happen. And the standard oxidation potential, learn it. It will be very, very beneficial when you will go for metallurgy as well. The standard oxidation potential, the oxidation of water when it happens at anode, is minus 1.23 volt. I hope it is clear. Similarly, we have also the reduction of water happening at cathode. What is that reaction? It takes away 2 electron, it accepts 2 electron, and you have to balance the charge, and it will give you hydrogen gas. For balancing the charge, because it accepts 2 electron, you have written OH minus here. So it means when you have this reaction, concentration of OH minus will increase. It means pOH will decrease. It means pH will increase. Correct? This is what we have to learn. And boys and girls, यहाँ पे मैं लिख देता हूँ, your pH will decrease, right? Acha. You have to learn the SRP. This is nothing but SRP. In short, SRP of water when it undergoes reduction at cathode is minus 0.83. SOP of water when it undergoes oxidation is minus 1.23. You have to learn these values. ये learn करनी है. Is that okay? ये learn करोगे? Everyone promise me. Would you learn it? Let me know. I am seeing here because my mobile phone is right there and I am seeing the comments. Correct? You have to learn this data. Very, very important. I'll show you how I am going to use it in today's session. Right? So make sure you learn it. It's very important. Okay. Now check this out, boys and girls, ladies and gentlemen. Pay attention. Example: electrolysis of aqueous copper sulfate using platinum electrode. Platinum is inert in nature, so it will not bother or it will not hinder the reaction which is happening. Beta, if I say aqueous solution means water is there, aqueous automatically means water is there, right? So what is happening? Copper sulfate will be present in the form of Cu plus 2 ion and SO4 2 minus, right? I hope everyone is understanding. So what you are doing, you are hooking up the electrodes, you are putting your electrodes. Acha, important thing, if you have noticed here, you are going to use a setup in which both anode and cathode are put in a same cell. But in galvanic cell, you are using two different half cells. यहाँ half cell की जरूरत नहीं पड़ती. Okay, यहाँ you use only one cell. You in the one setup you add in an anode and cathode. So what is happening, beta? Now what is happening here? Check this out. It's very important. Very, very important. So beta, electrolysis of aqueous copper sulfate, you have Cu plus 2 ion in the solution, you have copper sulfate ion, so Cu plus 2 and SO4 minus 2 in the solution. Now at anode, basically anode is of positive charge, and at anode oxidation happens, right? Oxidation will happen, right? At anode oxidation will happen. Now what is going to happen? Sulfate ion, if you talk about, what is the oxidation number of sulfur in sulfate ion? Is it plus 6? Is it plus 6? And you guys know sulfur can show maximum oxidation number of plus 6. It is at highest level. It cannot go for further oxidation. It cannot go for further oxidation. Correct? Am I correct? ये further oxidation के लिए नहीं जा सकता. बोलो बेटा. Let me know in the chat box. Yes, it cannot be further oxidized. So water, because it is also a competitor ion, because there is aqueous solution. As a result, water will undergo oxidation and you will get oxygen gas at anode. I hope you're understanding, right? I hope you're understanding. सबको clear हो गई ये बात. Clear है? तो आपने यहाँ से oxygen निकाल लिया. When you dipped your electrodes in copper sulfate solution, aqueous copper sulfate solution at anode, oxygen will be liberated. Simple fact. Moving on. Now at cathode, beta, what will happen? Pay attention. Very, very important. At cathode, you have a competition between copper plus 2 and H2O. Whichever is having higher SRP will undergo reduction. Higher the SRP, higher will be the reduction tendency. So copper, which is I have shown it by blue color. Copper will undergo reduction. Copper will undergo reduction. So you will get copper deposited at your cathode, and you will purify, or you will remove copper from the aqueous copper sulfate solution. Clear? Yes, so you have removed copper from copper sulfate solution. How awesome is that? Now it brings up to a very important question in metallurgy. Beta, tell me, if I would have taken any metal other than copper, where SRP of water is less than SRP of water, so I said it wrong, where SRP of the metal is less than the SRP of the water, the reduction of water would have would have happened. For example, if I take sodium, sodium SRP value is somewhere near minus 2 volt. So which is bigger, water or sodium SRP? Which is higher, water or sodium? Let me know, water or sodium? Waiting for your response. Water? Water is more. So water would be, as a result, hydrogen gas would be liberated. As a result, hydrogen gas would be liberated. I hope it is clear. It's a very important point. So you have to, what they will do in metallurgy, am I visible? Beta, am I audible and am I visible? I think there is a lag issue or something. Am I audible? मैं सुनाई दे रहा हूँ, दिखाई दे रहा हूँ? I think it's all right. All right, ठीक है. बढ़िया, बढ़िया, बढ़िया. Very nice, very nice. Very good, very good. ठीक है. So boys and girls, again the lag has come up. 1 second, give me a second. It's okay, it's fine, right? All right, just give me a second, 1 second. I think it's my food. I have to pick this call. Hello. Hello. हाँ सर, doorstep is what we order. Doorstep for me. All right. All right. So, boys and girls, so very important point of metallurgy, that if the metal is having SRP value, the standard reduction potential of metal, if it is smaller or lower than the SRP of water, then water will undergo reduction and you will get hydrogen gas at the cathode, not the metal. So, sodium, potassium, magnesium, calcium can never be extracted from its aqueous solution. They have to be taken in molten form. अगर पानी रहेगा तो पानी competition जीत जाएगा. If there will be a competition between metal and water at cathode for reduction, if the metal SRP is less than water SRP, then the reduction of water will be preferred. Correct? Higher the SRP, higher will be the reduction. इज दैट क्लियर? क्या मेरा पॉइंट समझ आया? बहुत हैवी पॉइंट दिया है मैंने यहाँ पर. ये क्वेश्चन आता ही आता है. आप देखिए, यू चेक आउट मेनी प्रीवियस ईयर क्वेश्चंस. ठीक है, मेनी प्रीवियस ईयर क्वेश्चन ऑफ जेई, यू विल गेट दिस क्वेश्चन डेफिनेटली. ठीक है, ये आपको फिर से क्वेश्चन मिल जाएगा, हमेशा काफी बार पूछा गया है. इट इज लिंक्ड विद मेटलर्जी एज वेल एज इलेक्ट्रोकेमिस्ट्री, राइट है. सो आई हैव गिवन यू राइट हियर दिस पॉइंट. सबको समझ आया? तो नाउ आई एम कमिंग ऑन टू द नेक्स्ट वन. दिस पॉइंट you can conclude, I can conclude with this, right? I can conclude the point. Metals having value of SRP, more value of SRP than SRP of water, can be obtained by electrolysis. From aqueous electrolysis you can do, otherwise you have to take their molten form, because competition was won by water if the SRP was less as compared to water. So you have to make sure you use those metals in aqueous form or in its aqueous solution, where SRP of metal is more than SRP of water. ठीक है? All right. ठीक है. Now check this out. Next, I am going here only. NaCl की electrolysis पे देखो. So next is electrolysis of aqueous NaCl. Very important, very nice. देखो, so what will happen? You are passing electricity through your aqueous NaCl. You know what is brine solution? 30% of NaCl solution is called as brine solution in water. Of course, when you add 30% of NaCl in water, you get brine solution. तो आपको brine solution मिल जाता है. तो आपको ब्राइन सोल्यूशन मिल जाता है. बेटा जिसको थोड़ा सा नहीं समझ आया, कैन रिपीट, आप उसको देख सकते हो. यू कैन वॉच, यू हैव द ब्यूटीफुल फैसिलिटी, यू कैन आफ्टर द सेशन यू कैन डेफिनेटली वॉच इट अगेन. ठीक है, जो पॉइंट था काफी को समझ आ गया, इसलिए मैं आगे बढ़ जा रहा हूँ. दैट्स व्हाई आई एम मूविंग फॉरवर्ड. नाउ चेक दिस आउट. I have aqueous solution. So at cathode, what are the competitions? What is the competition we have? Na plus versus water, right? Now sodium SRP is very low. No need to learn, but remember it is very low as compared to SRP of water. So you will get hydrogen gas at cathode, sorted. So when you will do electrolysis using aqueous NaCl, you are not going to get sodium metal. That was my last point. Continuing the point here. Now check this out. This is a kind of an exception also. Anode, when I take anode, when I talk about anode, we have a competition between Cl minus and water again. But a Cl minus SOP is less and SOP of water is high. Higher the SOP, higher will be the tendency to undergo oxidation at anode. Higher the SOP, higher will be the tendency to undergo oxidation at anode. That's the normal trend. That's the normal trend. बट देखो जरा यहाँ पर इंपॉर्टेंट लेसन है. देयर इज अ वेरी इंपॉर्टेंट लेसन. देयर इज अ वेरी इंपॉर्टेंट लेसन. पे फुल अटेंशन. लेसन क्या है बेटा? काइनेटिकली इट हैज बीन फाउंड दैट द rate of reaction, the speed by which the reaction or the oxidation of water is happening at anode is kind of very slow. काफी slow रहती है. So you, as a result, to increase the pace of the reaction, you pass some electricity, extra current you pass, extra potential you apply. And Cl minus is an opportunist. It sees, okay, I have a charge, negative charge, you are giving some more positive charge. This is called as over potential. Cl minus, which was not ready for oxidation, will undergo oxidation. It is just like that case when you are preparing, many students are preparing for the entire year, and some of you have started preparing in the last 3-4 months and you have achieved the target just like them. You have also cracked your IIT. So they are opportunities. They realized, okay, potential was increased. Now because I have a negative charge on me, I can move faster. So they were very opportunist and they actually did it. Understood? This potential to increase the rate of oxidation is called as over potential or extra potential. right? And Cl minus being the opportunist will go for oxidation. This is a very good exception. Cl minus beta yaad rakhna, Cl minus will undergo oxidation to give you chlorine gas. So when you do aqueous NaCl, when you take aqueous NaCl and you do electrolysis, you are never going to get sodium. You are never going to get sodium. You are never ever going to get sodium. How can you get sodium? If I want to obtain sodium, if I want to obtain sodium from your NaCl, what should I do then? I am in a big conundrum, right? It's bit of a dilemma, right? I am in a dilemma, I am in a conundrum, I am in all the good words you have put it there, right? Kind of a terrible situation for me. So what shall I do? What shall I do? जल्दी बताओ क्या करूं मैं फिर? If I want to get Na from NaCl, which form I should take? Very good Mohit, I should take molten NaCl. ये बात करी. Very good Dipendu. Ritish, all right. तो ये Ritika, Siddharth has also given. Siddharth says don't know. Honest answer. Very good. So who got the answer correct? Who said it was molten form? You have to give me a like for this, and you have to subscribe if you're a new subscriber. If you're a new person here, so make sure you like because you got something new. आपको समझ आ गया है? All right, amazing. Moving on. आगे बढ़ूंगा. अब यही तरीका मैंने आपको बताया. इंडस्ट्री में यही तरीका चलता है. We actually use aqueous NaCl if you want to produce hydrogen and chlorine gas. We use brine solution. We take 30% of NaCl in water and do what do you call uh, this electrolysis, and side product is NaOH. Caustic soda is produced as a side product, which is also an industrial preparation, which is also an industrial way of preparing this, right? Let me make a table so you can remember it. One second, boys and girls. Hanji. So when you take aqueous form, I'm giving you a very simple hint. Check this out. एक तरीका दे रहा हूं मैं आपको याद करने का. When you take aqueous NaCl, what you are going to get at anode? At cathode you are going to get H2 gas. This is at your cathode. This is the simple way you can remember. At particular point at the Cl minus you will get chlorine gas at anode. This is how you can remember entire aqueous NaCl electrolysis. And OH minus is there, so it means, and Na plus is there, basically you are going to form NaOH out of it, right? You are going to form NaOH out of it. So it's a beautiful, this is our side product, and side product is very effective for us right now. Side product is caustic soda, right? I hope you understood. This is a way of remembering everything within a second. एक circle बनाना. This is the simple layout. I have learned like this. I am giving it to you. ठीक है? My secret is with you now. All right. Moving on. The most important thing, and a beautiful cell बेटा, बहुत amazing cell है ये, बहुत ही amazing cell है, और ये बहुत important है. ये बहुत important है. ये आपका मेटलर्जी के अंदर भी आने वाला है. So अभी ध्यान से सुन लो. Pay full attention. I want full dedication right now. This will come again in the chapter called metallurgy. If you will pay attention now, you will understand better. Let me know you are understanding in the chat box. बच्चे जल्दी बताओ. Start करूं क्या ये? Shall I start? Start कर दूं? Sajal is saying no sir. No thank you. Thank you very much. I am happy. All right. ठीक है जी. बढ़िया. All right, I'm happy. I'm having a good time right now, and please make sure you share the video, you subscribe to the channel, and you definitely like this video. I am telling you, if you're my sailor and you're not liking my stuff, I hate you all then. है ना? Very big word, hate. I don't hate you, but I won't be happy with you. So let's do this. Let's start. देखो, forget about the cell right now. Forget about the cell. इसको मत देखना, don't see it right now. Let me make a high. You know, don't see it right now. Don't see it right now. We'll come back to it. Now we are using aqueous CuSO4. Just now we have seen, but we are using copper electrode. Copper electrode is no longer inert; it is active. It will participate in the reaction. So let's see what will happen. So at anode we have three competitor ion. We have sulfate ion, we have H2O, and at anode we have also copper, because the electrodes are made up of copper. These electrodes you see na beta, they are made up of copper. They are made up of copper. So they are participating in the reaction. So beta, copper SOP is very less, minus 0.34. SOP of your what do you call is even lesser, water. And sulfur can never undergo oxidation because it is at the maximum state right now. So there was a competition that whether copper will undergo oxidation or your what do you call your water will undergo oxidation. And it is no surprise, since you can see SOP here is more, copper will convert into copper plus 2. So oxidation will happen at anode, and copper will become, the copper from the electrode will become copper plus 2, right? वो copper plus 2 बन जाएगा. Check it out. At cathode again we have three competition. Cu plus 2 is there, water is there. SOP of Cu plus 2 is 0.34. SOP नहीं SRP, माफ करना, SRP, right? SRP of water is minus 0.83 volt. I told you already, minus 0.83 volt. So this is higher. Higher the SOP, higher the SRP, higher will be the tendency for reduction. So what is the overall reaction? Can you tell me? Isn't it this? That copper is giving you Cu plus 2, and similarly Cu plus 2 is getting deposited to give you copper. यही तो है net cell reaction. Let me show you. From anode, copper is giving you copper plus 2. Copper plus 2 is giving you copper cathode. Right? This is what it is happening. क्या दिख रहा है ये आपको net cell reaction? ये बड़ी important है. Now what is the use of it? अब देखते हैं, जरा समझो. How it is used, when it is used, why it is used. Check this out. Now see the setup. What I will do, check this out boys and girls, ध्यान से देना, सब सुनना, बहुत important है. Very important bit. In industry, what I will take impure copper. This is your impure copper. I will make it as cathode. I will plug it up as anode. This is anode. Right? This is anode. I'll make sure this will become anode. Very, very important process. Pay full attention. This will become anode. This is your cathode, right? Known. Simple fact, it is known to all of us. Now what will happen at anode? Oxidation will happen. This impure copper which you had will be converted into copper plus 2 ion. So can I say mass of copper at anode decreases? Is it a right fact? अच्छा मैंने लिखा है, आपको दिखेगा नहीं, यहाँ लिखता हूँ. Can I say mass of copper at anode decreases? Can I say yes or no? What is happening? You are converting your impure copper into copper plus 2 form. हाँ यार, बहुत समझदारी से प्रोसेस किया गया है. देखना कितने समझदारी से आप मेटलर्जी में काम करते हो. Pay full attention. I require your highest of wit right now. You should be witty, understanding this process. Your mind should be focused. Are you there with me? क्या आप वो देख पा रहे हो जो मैं देख रहा हूँ? हाँ? So copper, impure copper has been converted into copper plus 2 form. Right? This copper plus 2 form, beta, now see. Cathode पे ये आपने जो electrode लगाया, this is of pure copper. Very thin. It is a very thin strip. It is a very thin strip. ये बहुत छोटी सी पतली सी strip होती है, very thin strip. Whereas your anode is a chunky one. It's a bulky electrode. Bulky electrode, impure electrode, right? So you are converting your impure electrode into copper plus 2 form. As a result, mass of the anode will decrease. The mass of the anode, the thickness of that electrode which is at anode will decrease. वो कम होती रहेगी. Now this Cu plus 2 will be tempted towards this pure copper, and there will be oxidation. It will start getting deposited. It will be starting depositing. It will be deposited there, I should say. It will start getting deposited there. As a result, mass of copper, I hope everyone can see, mass of copper at cathode increases, and now you are able to get your impure copper, you are able to convert your impure copper into pure copper. आपने pure copper बना लिया देखते ही देखते, समझे? अच्छा, ये जो impure copper होता है, it also gives out some impurities which is called as anode mud. It is called as anode mud, and it is not mud actually. It contains the impurity of silver, gold, platinum. This question has also come up in JEE from metallurgy. This process, this impure copper also has some impurities of silver, fine impurities of silver, gold, and platinum, which is given further out to lab. It is not a mud, but we call it as anode mud. How stupid it is! Ironic, right? But yeah, it is called as mud. Clear? Anode mud. I hope it is clear, and it is given to labs for further treatment and further extraction of those precious metals. ठीक है? So ये process होता है. अब where it is used, no one asked me, sir ये कहाँ होता है, कौन से सेल के लिए होता है, किसके लिए कहाँ होता है, no one asked. Do you wanna know where we use it? We know we use it in metallurgy. ठीक है, किसी ने बोला सिद्धू has said sir electrolytic purifying ना, it's very good, I understand, but you know which metal, you know copper, copper is extracted, from CuFeS2. This is called as chalcopyrite. It is found mainly in India. ये इंडिया में पाया जाता है. This is called as chalcopyrite. It is a main source of copper, right? The copper which you receive from it is called as blister copper. It's called as blister copper, right? Blistered copper, right? Blister copper में होता क्या है बेटा? In Hindi, it is also called as fafoledar copper, right? Fafoledar copper. It has some impurities of sulfur dioxide trapped in it, right? Blister copper. We call it as blister copper, right? So, ये impure copper को further we purify. Question has come up in JEE again. You can check it out. How do we we use the refining for copper? What is the process? You will say electrolytic refining. And copper is extracted from which ore? Copper. This is called as chalcopyrite. Okay? The name of the pyrite or the ore. This is the ore from which the copper is extracted is called as chalcopyrite. Okay? So it is used for the purification of this ore. From there we will get copper, and then copper is purified. My mistake. Copper is purified further. Okay? I hope it is clear. सबको समझ आ गया है. ठीक है? Chalcopyrite is the ore from where we receive copper. I hope it is clear. Boys and girls, अगर मजा आया है, I had given you last. I dared all of you to solve this question. I gave you a dare, and many of you gave the answer. The answer is B option. So if your answer was correct, do let me know in the chat box. Say yes, I have given B as the correct answer, and I got it right. So you also, I will appreciate you if you would drop in a comment in the comment box and let me know. ठीक है? That's it बच्चा, आज का क्लास यहाँ खत्म होता है. And yes, if you are a 2020 student or if you are a student who has just finished 11th class and very confident, you can try this crash course, right? You can learn from us. We will give you content, we will give you live classes, we will give you previous year 11th 12th JEE problems of JEE pattern of JEE exams, the exams which had been conducted by JEE. Those questions we will give you, rigorous training we will give you, and not only for physics, not only for chemistry, not only for maths, it is for all the subjects altogether. This crash course is amazing, and you, best part in my personal humble opinion, you will get the teachers and you will get your information from them live. If you have a doubt, it will be cleared live, right? You will get all India rank from the test series we will conduct here. So you will also get to know where you are standing, so you can improve yourself and you can work on your abilities, or you will improve your skills better. It would be a very good tool for improving your knowledge, right? And it will make sure that you are regular and at it, right? And attacking your chemistry properly, physics also, maths also. And yes, if you will use my coupon code, that is HMCC, you'll get a discount. All you have to do is go into log on to this site. This site is also in the description box. Click on the description box and click on the link. Link will take you there. Use the code and you'll get a discount. Some of you ask me, sir, is this safe? Yes, beta, it's 100% safe. You're secured. You are going through a secured medium of payment. Paytm se bhi kar sakte ho, phone pay se bhi kar sakte ho. You can also use credit card or debit card, but make sure you use the coupon code. Otherwise, this is a course of around 25,000. I don't want you to pay 25,000. I want you to pay just 6,000 and you get the best benefit out of it. That's it for me today, beta. I hope you have loved it. And yes, who are joining in for the very first time, I am actually giving out, we have made a playlist. You can check out all the previous lectures and learn every day, evolve. Okay? Similarly, beta, Telegram, जरूर join करो. Why you have to join Telegram? Because we are there. We are posting assignments. We are giving you polls, asking your opinion. What do you want? What improvements shall we do to make our channel better? And you are interacting with us constantly there. So make sure you join this Telegram app. Join our channel. That is, Vedantu JEE, and learn from us. Link is in the bio. Similarly, like the video already. Please, my sailors, you have to like it. You have to share it. You have to subscribe. I have loved the session today. Whatever I have delivered, काफी मजा आया मुझे. I hope you felt the same. If you resonated with me, let me know in the chat box कि सर मुझे मजा आया, कुछ सीखने को अच्छा मिला. कल मिलेंगे फिर से next time. We are going to start kinetics. हम kinetics पढ़ने वाले हैं. बहुत मजेदार चैप्टर है. अच्छे से सीखेंगे. Thank you so much, and that's it for me today. See you next time.